Can three symbols explain everything? Tonight, we're going to explore the most revolutionary equation ever written, E equals MC². You've probably seen this formula thousands of times on t-shirts, in movies, scribbled on blackboards. But here's what most people don't realize. This isn't just abstract math. This equation reveals that your coffee cup contains enough energy to power a city, that you, sitting there right now, are made of compressed starlight. By the end of this journey, you're going to understand exactly why Einstein called this equation spooky, and how it connects the smallest atoms to the largest galaxies in ways that will completely transform how you see reality itself. Before we dive in, if you find these kinds of explorations fascinating, a quick like or subscribe really helps the channel grow. It's a small thing for you, but it makes a real difference for me. Get comfortable. Get comfortable. Let's begin. Picture this. It's 1905. Horse-drawn carriages still clatter down cobblestone streets. The Wright brothers have barely gotten their contraption off the ground for 12 seconds. Most homes are lit by gas lamps, not electricity. And in a small patent office in Bern, Switzerland, a 26-year-old clerk with wild hair is examining applications for new inventions during the day. But during his coffee breaks, Albert Einstein is quietly dismantling everything humanity thought it knew about the universe. He's not working in some grand university laboratory. He doesn't have access to expensive equipment or teams of assistants, just a desk, some paper, and a mind that refuses to accept what everyone else considers obvious. On a September afternoon in 1905, Einstein finishes writing a 3-page paper with an innocuous title. Does the inertia of a body depend upon its energy content? It's phrased as a simple question, almost conversational. Like asking whether the weight of your backpack depends on how much you've stuffed inside it. But this innocent question is about to detonate centuries of scientific certainty. Einstein doesn't even write the famous equation directly. Instead, he describes his discovery in a single German sentence that roughly translates to, if a body gives off energy L in the form of radiation, its mass diminishes by L divided by c². Read that again slowly. He's saying that when something releases energy, it literally becomes lighter. Not metaphorically lighter, actually measurably lighter. Think about what this means. When you burn a candle, the flame isn't just using the wax. It's converting tiny amounts of the wax itself into light and heat. The candle is literally disappearing, atom by atom, transforming into energy that dances in front of your eyes. But here's where it gets strange. Einstein realizes that this conversion works both ways. If matter can become energy, then energy can become matter. Mass and energy aren't just related. They're the same thing, wearing different masks. For over 2 centuries, scientists had treated mass and energy as completely separate entities. Mass was stuff, solid, permanent, measurable. A rock was a rock. Water was water. Your body was your body. These things had substance, weight, reality. Energy was movement, potential, force. The swing of a pendulum, the heat from a fire, the lightning in a storm. Energy was what happened to matter, not what matter was. Einstein is about to reveal that this distinction is an illusion. Let's break down what each symbol in MC² actually means, because understanding these letters will change how you see everything around you. E stands for energy. Not just any energy, all the energy locked inside any piece of matter. Every energy form you've ever experienced, the electricity powering your devices, the heat warming your home, the chemical energy your body extracts from food, the kinetic energy of a moving car. All of it. M represents mass, but not weight. Mass is more fundamental than weight. Mass is the amount of stuff packed into something. A gold ring has more mass than a plastic ring of the same size because gold atoms are heavier and more tightly packed. Mass is what gives matter its resistance to acceleration, its stubborn refusal to be pushed around easily. And c is the velocity of light, exactly 299,792,458 meters per second. Not approximately, exactly. This number isn't arbitrary, it's woven into the fabric of space and time itself. Now comes the crucial part. Einstein doesn't just multiply mass by the speed of light, he multiplies it by the speed of light squared. C2. Let me put this number in perspective for you. The speed of light squared is 89,875,517,873,681,764. That's nearly 90 quadrillion, 90,000 trillion, a number so large that if you wrote it out in normal-sized digits, it would stretch across this entire page. This is why Einstein's equation seemed impossible when he first proposed it. That enormous number means that even the tiniest amount of matter contains staggering quantities of energy. A single grain of sugar, something you could barely feel between your fingers, contains enough energy to power a small city for days if you could convert it completely. Your coffee mug, sitting innocently on your desk, harbors more energy than was released in some of the largest volcanic eruptions in human history. But here's the beautiful paradox. This energy isn't hidden or theoretical. It's there, right now, holding every atom in your body together. The scientific community of 1905 almost completely ignored Einstein's paper. They were busy with practical problems, improving steam engines, perfecting electric lighting, developing better telegraph systems. The idea that ordinary objects contained universe-destroying amounts of energy seemed like science fiction nonsense. Imagine trying to convince someone that a grain of sand could level a city block. They'd look at you like you'd suggested that ants could topple skyscrapers by walking in formation. The claim was so far outside normal experience that most physicists simply dismissed it as mathematical fantasy. But Einstein had done something unprecedented. He'd revealed that what we call matter and what we call energy are not different things. They're different states of the same fundamental reality. Like ice and steam are both water, matter and energy are both manifestations of something deeper, something that can flow from one form to another without ever being created or destroyed. This wasn't just a new scientific fact, it was a complete rewrite of reality. Think about conservation of energy, the principle that energy can neither be created nor destroyed, only transformed from one type to another. Einstein showed that this principle was incomplete. Energy can't be created or destroyed, but it can transform into mass. And mass can transform back into energy. The total amount of mass energy in the universe remains constant, but it can shift between forms in ways no one had imagined. When you eat food, your body isn't just extracting chemical energy, it's participating in ancient transformations that began in the cores of stars billions of years ago. The atoms in your breakfast were forged in stellar furnaces, where mass converted to energy to light up ancient skies, and now they're converting back to energy to power your thoughts, your movements, your very existence. But Einstein's equation also terrified some scientists who understood its implications. If ordinary matter contained such enormous energy density, what would happen if someone figured out how to release it? The equation predicted that converting just 1 gram of matter completely would release as much energy as burning 2,500 tons of coal. Some physicists worried that the wrong discovery might allow uncontrolled energy release that could crack continents or shatter planets. They were imagining scenarios where matter might cascade into energy in an unstoppable chain reaction that would consume everything in its path. Fortunately, Einstein's equation also reveals why such disasters don't happen spontaneously. The same forces that lock enormous energy inside matter also make that energy extremely difficult to access. Under normal conditions, matter is remarkably stable. The energy is there, but it's secured behind barriers that require extraordinary conditions to break. It took 27 years before anyone could experimentally verify Einstein's prediction. In 1932, John Cockcroft and Ernest Walton built a device that could split atomic nuclei and measure the energy released. When they finally succeeded, they found that Einstein had been correct to within 0.5%. After decades of skepticism, the equation was proved right with stunning precision. The confirmation changed everything. Suddenly, Einstein's thought experiment became the foundation for technologies that would reshape civilization. Nuclear power, nuclear medicine, nuclear weapons, and eventually our understanding of how stars shine and how the universe itself operates. But perhaps the most profound impact wasn't technological, it was philosophical. MC² revealed that the solid, permanent-seeming world around us is actually a dynamic dance of energy in temporary equilibrium. Your desk isn't really solid. It's a pattern of energy so stable and long-lasting that it appears solid to your brief human perception. The walls around you, the ground beneath your feet, your own body, everything you've ever touched or seen is energy that has chosen to manifest as matter for a while. Like waves in an ocean that maintain their shape, while the water itself flows through them, matter is energy that has found stable patterns in the chaos of existence. Even in everyday processes that seem to have nothing to do with nuclear physics, Einstein's equation is quietly at work. When you burn wood in a fireplace, approximately 1/1000% of the wood's mass converts directly to energy. It's an amount so small that even the most sensitive scales can't detect it, but it's there. Proof that even the most mundane chemical reactions are actually tiny expressions of the universe's most fundamental relationship. Every candle flame is a microscopic demonstration of MC², every battery powering your electronics, every muscle contraction in your body. The equation doesn't just describe exotic nuclear processes, it describes the energetic foundation of everything that exists. This is why MC² has become more than a scientific formula. It's become a symbol of human intellectual achievement, appearing on t-shirts and coffee mugs and tattoos. It represents the moment our species discovered that we live in a universe far stranger and more wonderful than we'd ever imagined. 3 simple symbols that connect the smallest scales of reality to the largest. An equation that reveals every atom as a compressed star, every object as a reservoir of cosmic power, every moment as part of an eternal dance between matter and energy that has been choreographed by the fundamental laws of physics since the beginning of time. And we're just getting started, because understanding what these symbols mean is only the first step toward grasping the full magnitude of what Einstein discovered about the nature of reality itself. Look around you right now. What do you see? Maybe you're sitting at a desk, holding a coffee mug, surrounded by the ordinary objects that fill your daily life. A lamp, perhaps, some books, your phone, a pen. Every single one of these objects is a disguised star. That coffee mug you're drinking from, let's say it's a typical porcelain mug weighing about 200 grams. It looks innocent enough, useful, ordinary. But according to Einstein's equation, that harmless piece of ceramic contains the energy equivalent of 4,300 megatons of TNT. To put that in perspective, the largest nuclear weapon ever detonated was the Soviet Tsar bomber in 1961, which released 50 megatons. Your coffee mug contains roughly 86 times more energy than the most powerful explosive device ever created by humans. The pen in your hand? If you could convert its mass completely, it would release enough energy to power a small city for months. That smartphone you check dozens of times a day harbors more destructive potential than entire military arsenals. You are literally surrounded by compressed starlight masquerading as household items. But here's the question that probably just occurred to you. If ordinary objects contain such staggering amounts of energy, why doesn't everything around you spontaneously explode? The answer reveals one of the universe's most elegant safety mechanisms. The energy locked inside matter isn't hidden by accident. It's secured behind barriers so formidable that accessing it requires conditions found only in the cores of stars or the heart of nuclear reactors. Think of it as the ultimate cosmic vault, where the combination is written in the fundamental laws of physics themselves. To release the energy from your coffee mug, you'd need temperatures exceeding millions of degrees, hot enough to strip electrons completely away from their atoms and smash atomic nuclei together with such violence that they overcome the electromagnetic force trying to push them apart. Or you'd need pressures millions of times greater than what you experience at the bottom of the ocean. Under normal Earth conditions, atomic nuclei are held together by the strong nuclear force, one of the four fundamental forces of nature. This force is incredibly powerful at short distances, but it operates only within the confines of atomic nuclei. It's like having an unbreakable lock that can only be opened with keys made of pure energy that barely exist in our everyday world. This is why you can drink your coffee in peace, instead of worrying about accidentally triggering a thermonuclear explosion. But here's where it gets interesting. Although the massive energy stores remain locked away, tiny amounts are being released constantly all around you through much gentler processes. When you burn a piece of paper, you're not accessing nuclear energy. You're releasing chemical energy, the much smaller amounts stored in the bonds between atoms. Think of it like rearranging furniture in a house versus demolishing and rebuilding the entire structure. Chemical reactions shuffle atoms into new molecular arrangements, releasing modest amounts of energy in the process. But even in that simple chemical reaction, Einstein's equation is quietly at work. When the paper burns, approximately 1/1000th of 1% of its mass actually converts directly to energy. The amount is so small that the most sensitive laboratory scales can't detect it, but it's there, a microscopic demonstration of MC² happening on your desk. Now, consider your own body for a moment. You probably weigh somewhere around 70 kilograms. According to Einstein's equation, your body contains approximately 6.3 billion terajoules of energy. That's enough to power New York City for 150 years. You are, quite literally, a walking power plant that makes nuclear reactors look like dying flashlights. Every atom in your muscles, your bones, your blood, your brain, they're all tiny reservoirs of cosmic energy. The calcium in your teeth contains enough power to level city blocks. The iron in your blood could energize entire neighborhoods. You're not just made of stardust, as Carl Sagan famously said. You're made of compressed, concentrated, temporarily organized starlight. But again, that energy remains safely locked away. The same nuclear forces that guard the energy in your coffee mug protect the energy in your cells. Your body temperature of 37 degrees Celsius is nowhere near the millions of degrees required to break those nuclear bonds. Even a single grain of rice, something you might not give a second thought to, contains energy equivalent to 550 tons of TNT, enough to vaporize an entire city block. The next time you're eating dinner, remember that each grain on your plate harbors the explosive potential of a massive bomb. This isn't science fiction or theoretical speculation. This is the simple mathematical reality of MC² applied to the matter around you. Yet despite carrying this cosmic arsenal in every cell, you're perfectly safe. The energy release that keeps you alive comes from breaking and forming chemical bonds. processes that access only the tiniest fraction of matter's total energy content. When you digest food, your body releases approximately 0.1% of the food's mass energy content. That microscopic percentage is enough to power your thoughts, your movements, your heartbeat, and every biological process that keeps you alive. It's like having access to an ocean of water, but using only a few drops to irrigate an entire garden. Biological systems have evolved to be extraordinarily efficient at extracting exactly the amount of energy they need while leaving the vast nuclear energy stores completely untouched. Modern scientific instruments can actually detect these tiny mass-to-energy conversions happening in real time. When you light a candle, sensitive equipment can measure the infinitesimal decrease in the candle's mass as tiny amounts of wax literally disappear and become light and heat. When you burn wood in a fireplace, precision scales could theoretically detect that the remaining ash weighs slightly less than the original wood. These measurements require incredibly sophisticated technology, but they prove that Einstein was right down to the smallest observable scales. Every flame, every chemical reaction, every biological process, they're all converting tiny amounts of mass into energy exactly as his equation predicts. Consider a single drop of water, something so simple you barely notice it when it falls from your faucet. That drop, weighing perhaps 50 milligrams, contains 1.1 megatons of energy potential. More than many nuclear weapons. Enough to provide electricity to a small city for years. You shower in energy. You swim in energy. You drink energy. Every raindrop is a compressed star waiting for the right conditions to reveal its true nature. Einstein himself became fascinated by this hidden reality in everyday objects. He would spend hours contemplating the most mundane items, clocks, elevators, trains, coffee cups, because he understood that each ordinary object was actually an extraordinary concentration of cosmic forces. Imagine seeing the world through Einstein's eyes. Every chair becomes a throne of compressed energy. Every doorknob becomes a handle to the universe's power. Every book becomes a collection of thoughts printed on concentrated starlight. The mundane world transforms into a landscape of barely contained cosmic forces. Even the processes of life itself demonstrate these principles. When plants perform photosynthesis, converting sunlight into chemical energy, approximately 1/1,000,000,000% of molecular mass actually converts in the process. It's such a minute amount that it requires the most sensitive equipment to detect, but it's happening constantly. Every leaf, every blade of grass, every tree is quietly demonstrating MC² billions of times per second. The oxygen you breathe, the carbon dioxide you exhale, these simple molecules are products of countless tiny mass energy conversions that have been occurring for billions of years. You're participating in an ancient dance of matter and energy that connects your breath to the nuclear fires of distant stars. Your body temperature itself is a form of energy in motion. At 37 degrees Celsius, every atom in your body is vibrating, jostling, moving constantly. This thermal motion represents kinetic energy, energy of movement. And according to Einstein's equation, motion and mass are intimately connected. Your body warmth is actually matter in motion, demonstrating the fluid relationship between mass and energy at the most basic level. When you feel warm, you're feeling the universe's fundamental energy expressing itself through the organized matter that temporarily forms your physical existence. The fact that objects don't disappear around us reveals another beautiful aspect of these processes. The mass-to-energy conversion in normal chemical and biological processes is so infinitesimally small that an object would lose only a few atoms over millions of years. A mountain might lose the equivalent of a few grains of sand over geological timescales. To human perception, the world appears stable and permanent. But on cosmic timescales, everything is slowly, gradually converting between mass and energy in an eternal dance that has been going on for billions of years and will continue for billions more. Even the materials we create, plastics, metals, synthetic compounds, contain exactly the same energy density as natural materials. A plastic spoon has the same energy potential per gram as a wooden spoon or a silver spoon. Human creativity and technology don't change the fundamental laws of physics. They just reorganize universal energy into new, useful configurations. The laptop you're reading this on contains enough energy to power itself for millions of years if that energy could be accessed. The building you're in harbors more energy than has been used in the entire history of human civilization. Understanding this transforms your relationship with the physical world. That lamp illuminating your room becomes a temporarily organized collection of cosmic forces. Your favorite coffee mug becomes a fragment of stellar energy that has chosen to manifest in a form useful for holding beverages. Your home becomes a carefully arranged museum of concentrated starlight, organized by human intelligence into patterns that serve daily life. You're not just living in the universe, you're living inside a universe that has temporarily disguised itself as your familiar surroundings. Every object you touch, every surface you lean against, every tool you use is participating in the same fundamental energy relationships that power galaxies and create new stars in distant corners of space. The boundary between the cosmic and the domestic dissolves. Your kitchen becomes a laboratory where ancient stellar processes continue their work on a scale so gentle you can safely participate in them. Your bedroom becomes a chamber where organized starlight rests and regenerates itself for another day of existence. This is the hidden reality that MC² reveals. You don't just live in a universe. You live as a universe, temporarily organized into the form of a conscious being, surrounded by a cosmos that has chosen to masquerade as the comfortable, familiar world of human experience. But to truly understand the magnitude of what Einstein discovered, we need to journey deeper, from the familiar scale of coffee mugs and grains of rice into the bizarre realm of atoms themselves. Picture an atom. You've probably seen the classic diagrams in textbooks, a neat little solar system with electrons orbiting a central nucleus like planets around a sun. But the reality is far stranger than any diagram could convey. If you could somehow magnify an atomic nucleus to the size of a ping-pong ball sitting at the center of a football stadium, the electrons would be orbiting somewhere up in the furthest bleachers. And everything in between, empty space, pure, absolute nothingness. An atom is 99.99999% empty space. The period at the end of this sentence contains trillions of atoms, each one mostly void. You are mostly void. The chair you're sitting on is mostly void. The ground beneath your feet is mostly void. But here's the mystery. If atoms are essentially empty, why don't you fall through your chair? Why doesn't your hand pass through the table? Why does anything feel solid at all? The answer lies in invisible forces dancing in that apparent emptiness, electromagnetic fields and nuclear forces that create the illusion of solidity through pure energy. You're not sitting on matter in any traditional sense. You're being held up by force fields, by organized energy that has learned to masquerade as solid reality. Now zoom into that ping-pong ball nucleus at the stadium's center. Inside this impossibly tiny space, protons and neutrons are crammed together with mind-bending density. Each proton carries a positive electrical charge, and like magnets with the same pole facing each other, they should violently repel each other with tremendous force. By all rights, every atomic nucleus should tear itself apart instantly. The electromagnetic force trying to push those protons apart is enormously powerful. Yet somehow, the nucleus holds together. Something even stronger keeps it intact. That something is the strong nuclear force, one of the four fundamental forces of nature. This force is so powerful that the energy holding a single atomic nucleus together equals millions of hydrogen bombs. Every atom in your body contains this miniature sun of pure energy, held in perfect balance by forces we're only beginning to understand. Think about this. There are approximately 7 octillion atoms in your body. That's 7 followed by 27 zeros. Each one contains energy equivalent to millions of hydrogen bombs. You are a collection of cosmic explosions held in temporary equilibrium by the fundamental forces of the universe. For decades after Einstein published his equation, this nuclear energy remained purely theoretical. Then, on December 2nd, 1942, everything changed. In a converted squash court beneath the University of Chicago, physicist Enrico Fermi and his team achieved something unprecedented in human history: the first controlled nuclear chain reaction. For the first time, human beings had learned to unlock the energy that powers stars. It was like learning to light the first fire, but instead of accessing chemical energy stored in wood, they were accessing the nuclear energy stored in matter itself. They had opened the cosmic vault. What Fermi achieved was nuclear fission, the splitting of atomic nuclei. When a uranium-235 nucleus absorbs a neutron, it becomes unstable and splits apart, releasing energy according to Einstein's equation. The process releases 200 million electron volts per fission, enough energy to make a microscopic particle visible to the naked eye if you could somehow see it jump. But here's what makes this extraordinary. A single fission event releases energy equivalent to burning 3 billion carbon molecules. It's as if a grain of sand suddenly produced as much heat as an entire bonfire. Nuclear reactions operate on a completely different energy scale than the chemical reactions we're familiar with. This is why a single uranium pellet, the size of your fingertip, contains as much energy as a ton of coal. Why nuclear power plants can generate enormous amounts of electricity from relatively small amounts of fuel. Why nuclear weapons can release devastating amounts of energy from packages small enough to fit in a briefcase. Einstein himself was horrified by the military applications of his discovery. Although his equation made nuclear weapons possible, he spent the final years of his life advocating for nuclear disarmament. He realized that humanity had learned to access stellar energy before developing the wisdom to use it responsibly. We had become children playing with cosmic fire. The atomic bomb dropped on Hiroshima converted approximately 0.7 grams of matter, less than the weight of a paperclip, into pure energy. That tiny amount of mass, transformed according to MC², released energy equivalent to 15,000 tons of conventional explosives. Everything within 500 meters of ground zero was instantly vaporized, proving in the most dramatic way possible that Einstein's abstract equation described very real, very powerful forces. But nuclear fission, destructive as it can be, is actually the gentler of the two nuclear processes. To understand the true power hidden in matter, we need to look at what happens in the hearts of stars: nuclear fusion. Inside the Sun, 620 million tons of hydrogen fuse into 616 million tons of helium every second. 4 million tons simply disappear, converted into energy that radiates out into space. This energy has been streaming from the Sun for 4.6 billion years, providing the light and heat that makes life on Earth possible. The temperatures required for fusion are almost incomprehensible: 15 million degrees Celsius. At these temperatures, atoms are completely destroyed. Electrons are stripped away, leaving bare nuclei that collide with such violence they overcome the electromagnetic force, trying to keep them apart and fuse together, releasing enormous amounts of energy in the process. You might wonder why stars don't explode instantly from these continuous nuclear explosions. The answer is one of the universe's most beautiful balancing acts. Gravity compresses the stellar material with pressures trillions of times greater than Earth's atmosphere, creating conditions where fusion can occur. But the energy released by fusion pushes outward, fighting against gravitational collapse. Stars exist in perfect equilibrium between these opposing forces. Gravity trying to compress them into a point, nuclear fusion trying to blow them apart. This balance can last for billions of years, creating cosmic lighthouses that burn steadily across the vast distances of space. Fusion is incredibly efficient compared to any energy source we use on Earth. It converts 0.7% of mass directly into energy. 10 million times more efficient than burning coal. This is why stars can shine for billions of years while consuming relatively small amounts of their total mass. They're cosmic lighthouses that never need their batteries changed because they transform their own structure into light. Every ray of sunlight that touches your face carries the signature of nuclear fusion. Every photon has traveled 93 million miles from reactions that converted matter into energy, according to Einstein's equation. When you feel the warmth of sunlight on your skin, you're feeling the universe's most fundamental transformation made manifest. We can detect these stellar nuclear processes from incredible distances, using telescopes that analyze the light from distant stars. Each wavelength of light carries information about the nuclear reactions that created it. By studying starlight, we become cosmic archaeologists, reading the signatures of matter-energy conversion happening trillions of miles away. Some stars end their lives in explosions called supernovas that release more energy in 10 seconds than our sun will produce over its entire 10 billion-year lifespan. These cosmic cataclysms convert masses equivalent to entire planets into shockwaves that can be seen across galaxies. They're like cosmic flashbulbs announcing the death of a star and the birth of new elements. This is how elements heavier than hydrogen and helium came to exist. Inside massive stars, nuclear fusion creates carbon, oxygen, silicon, iron, all the elements essential for planets and life. But elements heavier than iron require so much energy to create that they can only be forged in the extreme conditions of stellar collapse, when gravity compresses matter to densities beyond imagination. The gold in jewelry, the platinum in catalytic converters, the uranium in nuclear reactors. These elements were created when massive stars died in cosmic explosions that briefly outshone entire galaxies. Every heavy element on Earth is the product of stellar alchemy, powered by MC². Our sun converts 4.26 million tons of mass into energy every second. That sounds like an enormous amount, but compared to the sun's total mass of 2 octillion tons, it's barely noticeable. The sun could continue at this rate for another 5 billion years before running out of fuel. Think about the precision of this cosmic engine. For billions of years, it has maintained nearly constant energy output, providing stable conditions for life to evolve on Earth. The fusion reactions in the solar core are so perfectly balanced that they create a steady energy source more reliable than any human technology. From space, high-energy particles called cosmic rays constantly bombard Earth. Some of these particles carry energy equivalent to tennis balls traveling at highway speeds, but concentrated in single protons. They're evidence of cosmic particle accelerators far more powerful than anything we can build, stellar explosions and black holes that use MC² as a universal motor to accelerate matter to nearly the speed of light. These cosmic particles are messengers from the most violent events in the universe, carrying energy signatures that tell us about processes happening in distant galaxies billions of years ago. Planets like Earth don't shine like stars because they lack the mass necessary to compress hydrogen to fusion temperatures. We're like wet wood that never gets hot enough to ignite. Instead, we depend on external stellar energy while remaining cold and dark in the cosmic night. But this limitation is also what allows complex chemistry and life to exist. The gentle temperatures on planetary surfaces permit the intricate molecular dances that create and sustain living systems. By measuring the cosmic microwave background radiation, the afterglow of the Big Bang itself, astronomers can apply MC² to calculate when the universe began. Every ancient photon carries information about the primordial mass-energy conversion that created space, time, and matter. Our telescopes have become time machines that read the energetic history of the universe, written in light, that has traveled for nearly 14 billion years. The elements in your body, the carbon in your proteins, the oxygen in your blood, the iron in your hemoglobin, were all forged in stellar cores through nuclear fusion governed by Einstein's equation. You are quite literally made of stardust, reorganized by biological processes into the temporary pattern that constitutes your physical existence. Life itself is a direct consequence of stellar nucleosynthesis. Without nuclear fusion creating heavy elements and dispersing them through space via stellar explosions, there would be no rocky planets, no complex chemistry, no possibility for the molecular complexity that underlies biology. The ultimate goal for human civilization might be to master controlled nuclear fusion on Earth, to build artificial stars that provide virtually limitless clean energy. This would represent our species' graduation from planetary energy sources to stellar energy sources, transforming us into a truly cosmic civilization. Imagine having access to the same energy source that powers the sun. We could terraform planets, travel to other star systems, and reshape matter itself according to our needs. We would become a species capable of stellar engineering, using the wisdom Einstein provided to light our own way to the stars. But before we reach for other worlds, let's consider the staggering energetic reality of the one beneath your feet right now. Earth weighs approximately 6 trillion kilograms. That's a 6 followed by 24 zeros. According to Einstein's equation, our planet contains 5.37 x 1041 joules of energy. This is a number so large that it defies comprehension through normal analogies. To put this in perspective, Earth contains more energy than all the stars in entire galaxies. Our planet is essentially a cosmic bomb disguised as a habitable world, patiently maintaining its current form while harboring enough energy to outshine billions of suns. If Earth's mass were somehow converted instantaneously into pure energy, the explosion would be billions of times larger than all the supernovas ever observed by human astronomers. The resulting fireball would vaporize not just our planet, but the entire solar system. Mercury, Venus, Mars, Jupiter, Saturn, everything would be consumed in an expanding sphere of plasma traveling at nearly the speed of light. From other galaxies, this event would appear as a brilliant new star suddenly blazing into existence where our solar system once was. The energy release would be visible across millions of light-years of space. Here's another way to think about Earth's energy content. Our planet contains the equivalent of 450 million years of the Sun's total energy output. The Sun, which has been powering life on Earth for 6 billion years and will continue for another 5 billion, could theoretically run for nearly 500 million years on the energy locked inside our planet alone. We're not just living on a world, we're living on a concentrated energy reservoir that dwarfs our local star. But why doesn't Earth spontaneously convert to energy? Why don't planets across the universe simply explode into pure light and heat? The answer lies in the fundamental stability of ordinary matter. Complete mass-energy conversion requires conditions that exist only in the most extreme environments in the universe, inside black holes or during the first moments after the Big Bang. The forces that hold atomic nuclei together are so strong, and the barriers to accessing nuclear energy so formidable that matter remains stable under virtually all normal conditions. Think of it as a cosmic safety system built into the very fabric of reality. The universe has constructed natural barriers that prevent catastrophic energy releases, allowing stable structures like planets, stars, and life itself to exist. Consider just the water on Earth's surface. Our oceans contain 1.37 billion cubic kilometers of water. That's 1.4 billion trillion tons of H2O molecules, representing 1.23 x 1040 joules of mass energy. At current global energy consumption rates, the energy in Earth's oceans could power human civilization for 400 trillion years. Every raindrop that falls from the sky, every wave that crashes on the shore, every glass of water you drink represents a concentration of cosmic energy that could revolutionize our existence if we could access it. You swim in energy. You shower in energy. You are made largely of energy in liquid form. Scientists can actually measure the energy content of planets using sophisticated techniques. By studying gravitational perturbations, the tiny wobbles that planets create in spacetime, astronomers can determine planetary masses with extraordinary precision. Apply EMC² and you can calculate the total energy content of any world. Every planet becomes a measurable cosmic battery. Every moon becomes a quantifiable energy reservoir. The mathematical tools Einstein provided allow us to assess the energetic potential of entire solar systems. Earth's atmosphere alone, weighing about 515 x 1018 kilograms, contains 4.63 x 1035 joules of energy. This is more energy than all the nuclear weapons ever built, multiplied by trillions. Every breath you take draws air from an ocean of concentrated energy so dense that each inhalation brings millions of billions of energetic atoms into your lungs. When you feel the wind on your face, you're feeling the movement of matter that contains more energy than human civilization has ever produced. Put this in perspective with the largest explosive events on Earth. The eruption of Krakatoa in 1883 was heard 3,000 miles away and created pressure waves that circled the globe 7 times. It released energy equivalent to 200 megatons of TNT, enough to power the United States for several days. Yet this colossal explosion represented only 0.0001% of the energy contained in the rocky material of that region. It was like striking a match next to a fuel depot the size of continents. Volcanic eruptions, devastating as they seem to us, are merely tiny sighs from Earth's vast energy reserves. Even Earth's rotation represents enormous energy storage. Our planet spins with kinetic energy equivalent to 2.57 1029 joules, roughly equal to the simultaneous detonation of 6.1 trillion tsar bombas, the most powerful nuclear weapon ever tested. This rotational energy has been maintained for over 4 billion years and will continue for billions more. Earth is like a cosmic top that never stops spinning, carrying enough momentum to power our modern civilization millions of times over. But this energy isn't accessible through any technology we can currently imagine. Extracting Earth's mass energy would require the ability to manipulate fundamental nuclear forces on a planetary scale. It would be like trying to disassemble a watch using hammers the size of mountains. Theoretically possible, according to physics, but practically impossible with our current understanding and capabilities. The same barriers that protect us from spontaneous planetary annihilation also prevent us from accessing these cosmic energy stores. Earth's gravitational field itself represents another form of energy storage. 2.28 x 1032 joules of gravitational potential energy. This invisible force not only keeps you anchored to the planet's surface, but actually curves the space-time around Earth, creating what Einstein called gravitational wells. Every step you take, every movement you make is influenced by this enormous energy field that transforms mass into geometry, literally bending the fabric of reality around our planet. You're not just held down by a force, you're living within a curved region of space-time created by Earth's energy mass. When we look beyond Earth to other worlds in our solar system, we see a hierarchy of energy storage. Jupiter, with 318 times Earth's mass, contains 1.7 x 1044 joules, enough energy to power trillions of advanced civilizations for eons. Even tiny Mercury harbors 2.95 at 1039 joules, which would still represent an unimaginable energy treasure for any species capable of accessing it. The solar system is revealed as a collection of energy repositories of vastly different scales, each one a cosmic battery maintaining its charge over billions of years. Even our moon, which seems modest compared to the major planets, contains 6.6 x 1039 joules of energy. This is enough to power all of human civilization for 200 billion years at current consumption levels. What we consider a small celestial body actually harbors energy resources that dwarf anything in human experience. Every night when you look up at the moon, you're seeing an energy reservoir beyond terrestrial comprehension. The motions of planets themselves store enormous amounts of kinetic and gravitational potential energy. Earth, traveling through space at 30 kilometers per second, carries energy equivalent to billions of supernovas. This energy is maintained in perfect dynamic equilibrium, preserving our orbital stability for billions of years through the elegant dance of celestial mechanics. The fact that planetary orbits remain stable over such vast timescales reveals the precision with which cosmic energy systems operate. Even asteroids, mere rocks tumbling through space, represent significant energy concentrations. A typical asteroid weighing millions of tons contains enough mass energy to destroy entire civilizations if it could be converted instantaneously. Every piece of space debris, every rocky fragment orbiting the sun, is a potential energy bomb floating silently through the cosmic void. When asteroids impact planets at velocities of tens of kilometers per second, they convert their kinetic energy into heat so efficiently that even tiny fractions of their total mass energy can create craters larger than cities. The Chicxulub impactor that ended the age of dinosaurs demonstrated MC² on a geological scale, reshaping Earth's climate through energy release. Deep within Earth, radioactive elements like uranium, thorium, and potassium undergo natural decay processes that slowly convert mass to energy over millions of years. Our planet is actually a natural nuclear reactor that has been heating itself from within for over 4 billion years, using atomic fuel distributed throughout its rocky structure. Earth radiates 44 trillion watts of heat continuously, like a cosmic light bulb glowing in the infrared, powered by the gradual transformation of matter into energy, according to Einstein's equation. Even the rings of Saturn represent enormous energy storage. Trillions of ice and rock particles orbit the gas giant with collective kinetic energy equivalent to millions of nuclear weapons. This energy is maintained in perpetual motion by gravitational forces that conserve angular momentum through complex celestial interactions governed by both Newtonian mechanics and relativistic effects. These beautiful rings are actually vast reservoirs of organized energy sustained by the interplay of gravity and motion across millions of years. All of this leads to a sobering realization about our cosmic future. In approximately 5 billion years, our sun will exhaust its hydrogen fuel and expand into a red giant star. When this happens, solar energy output will increase dramatically, and the inner planets, Mercury, Venus, Earth, and possibly Mars, will be vaporized. This future cataclysm will demonstrate MC² on the scale of entire worlds. Planetary masses will be converted into plasma and energy, their matter returning to the cosmic energy cycle from which it originally condensed billions of years ago. The solid ground beneath your feet will eventually become starlight once again, completing an ancient cycle of matter and energy that has been repeating throughout cosmic history. The energy locked within every world, every asteroid, every grain of cosmic dust connects our local solar system to the universal principles that govern all matter and energy. We live not just on a planet, but within a vast network of energy storage and transformation that extends from the smallest atoms to the largest cosmic structures, all operating according to the same fundamental relationship Einstein revealed in 3 simple symbols. But to truly grasp the magnitude of what Einstein discovered, we need to zoom out even further, beyond our solar system, beyond individual stars, to the scale of entire galaxies and the cosmos itself. Our home galaxy, the Milky Way, contains approximately 400 billion stars, each one a nuclear furnace converting mass to energy according to MC². The total mass of our galaxy is roughly 1.5 x 1042 kilograms, which means the Milky Way harbors 1.35 x 1059 joules of energy. This number is so staggeringly large that no earthly analogy can contain it. If every grain of sand on every beach on Earth represented the energy of our entire sun, you still wouldn't approach the energy content of our galaxy. The Milky Way is not just a collection of stars. It's a cosmic energy repository beyond all human comprehension. At the heart of each star, the same process repeats billions of times per second. 4 hydrogen nuclei, 4 protons, collide with such violence that they fuse into a single helium nucleus. But something remarkable happens in this transformation. The helium nucleus weighs slightly less than the 4 hydrogen nuclei that created it. That missing mass, just 0.7% of the original, doesn't simply disappear. It becomes energy, radiating outward as light according to Einstein's equation. This process is so efficient that a single teaspoon of stellar core material could power our entire civilization for 100,000 years. But even stellar fusion pales compared to the most energetic objects in the universe, quasares. These cosmic lighthouses emit energy equivalent to trillions of suns simultaneously, powered by supermassive black holes that can convert up to 40% of infalling matter directly into pure energy. 40%. Think about that for a moment. Stellar fusion converts less than 1% of mass to energy, yet quasares achieve efficiencies that would have made Einstein question whether his equation revealed only the tip of the cosmic energy iceberg. The very structure of galaxies demonstrates MC² on the grandest scales. Hundreds of billions of stars orbit galactic centers in elegant spiral patterns, their collective motion storing enormous amounts of kinetic energy. This rotational energy balances the gravitational attraction of trillions of stars, preventing galactic collapse and maintaining stable structures for billions of years. Galaxies are like cosmic whirlpools, dancing in slow motion through space and time, their spiral arms preserving angular momentum across distances so vast that light takes 100,000 years to travel from one side to the other. But perhaps the most mind-bending aspect of cosmic energy comes from the universe's beginning itself. In the first moments after the Big Bang, all the energy that would eventually become every star, planet, and living thing in the observable universe was compressed into a volume smaller than a subatomic particle. The energy density was so extreme that our current understanding of physics breaks down completely. Under those conditions, MC² might have operated in ways we can't even imagine, governing transformations between matter and energy that created the fundamental particles and forces that shape reality today. We can observe these ancient energy processes by studying light that has traveled billions of years to reach us. Every photon from a distant galaxy carries information about mass-energy conversions that occurred when the universe was young. Our telescopes become time machines, reading the energetic history of the cosmos written in starlight that began its journey before Earth even existed. Each ancient ray of light is a messenger from the primordial universe, revealing how Einstein's equation operated under conditions that will never exist again. But the universe holds an even deeper mystery: dark energy. Approximately 68% of the cosmos consists of this invisible force that pushes galaxies away from each other with ever-increasing strength. Dark energy may represent a form of energy so fundamental that it forces us to reconsider everything we think we know about the nature of energy itself. Unlike matter and radiation, dark energy doesn't dilute as the universe expands. Instead, it maintains constant density, creating more of itself as space grows larger. This challenges our basic assumption that energy is conserved, suggesting that the universe operates according to principles we're only beginning to glimpse. When galaxies collide, and they do regularly, the energy release defies imagination. The gravitational forces involved distort stellar structures and trigger massive star formation events, releasing energy equivalent to trillions of supernovas over hundreds of millions of years. These cosmic crashes reshape entire regions of space, demonstrating MC² on scales where individual solar systems become mere details in vast energetic transformations. Our own Milky Way is currently on a collision course with the Andromeda galaxy. In about 4 billion years, these two massive energy systems will merge in a cosmic dance that will remake both galaxies completely. Galaxy clusters, groups of thousands of galaxies bound together by gravity, contain total energy equivalent to 1060 joules. These are the largest gravitationally bound structures in the universe, with so much concentrated mass that they literally bend space-time around themselves. The gravitational fields of galaxy clusters are so strong they act like cosmic lenses, bending light from more distant galaxies and creating multiple images of the same object. We can actually see space-time being warped by energy, just as Einstein predicted. Black holes represent the ultimate expression of energy conversion efficiency. When matter falls into a black hole, it can convert up to 40% of its mass into pure energy, an efficiency that makes nuclear fusion look wasteful by comparison. Black holes are cosmic engines more powerful than stars, capable of outshining entire galaxies when they're actively feeding. The energy released by matter falling into a supermassive black hole can power quasars visible across billions of light years, making them among the most energetic phenomena in the universe. Even empty space itself contains energy. The cosmic microwave background radiation, the afterglow of the Big Bang, still permeates every cubic centimeter of the universe. This ancient energy maintains a temperature of 7 Kelvin above absolute zero, proving that the entire cosmos is bathed in the primordial energy of creation itself. You're not just surrounded by energy on Earth. You exist within a universe that is fundamentally energetic, where even the vacuum of space contains the echo of the most energetic event in cosmic history. We can actually calculate the total energy content of the observable universe. With an estimated volume of 4.65 in 1080 cubic meters, containing approximately 1.5 x 1053 kilograms of matter, the observable universe harbors 1.35 x 1070 joules of energy. This number represents everything that exists in material form, transformed through Einstein's equation into pure mathematical expression. It's the energetic inventory of all reality that we can possibly observe. Some of the most extreme energy events in the cosmos are gamma-ray bursts, explosions that release more energy in 10 seconds than our sun will produce during its entire 10 billion-year lifespan. These cosmic flashbulbs can be detected across billions of light years, briefly outshining everything else in their regions of the universe. A gamma-ray burst occurring in our galaxy could sterilize planets hundreds of light years away, demonstrating that MC² operates on scales where single events can affect the habitability of vast regions of space. But here's a sobering realization. Despite the universe's vast energy content, that energy is finite. Even with MC² allowing complete matter-energy conversion, the total amount of mass in the universe places an absolute upper limit on available energy. The cosmos is a closed system where energy can be transformed but never created from nothing, imposing fundamental constraints on what's physically possible, even for hypothetically advanced civilizations. Einstein also predicted that accelerating massive objects would create ripples in spacetime itself, gravitational waves that literally convert mass into geometric distortions traveling at light speed. When two neutron stars spiral into each other, they radiate energy as pure spacetime curvature, causing the fabric of reality itself to vibrate like waves on a cosmic ocean. These gravitational waves carry energy across the universe in the form of oscillating geometry, proving that mass and energy can transform into the very structure of space and time. Neutron stars themselves demonstrate matter under conditions so extreme they challenge comprehension. A teaspoon of neutron star material would weigh 6 billion tons on Earth. In these objects, protons and electrons are crushed together into pure neutrons, creating matter so dense that a city-sized sphere contains more mass than our sun. These cosmic laboratories reveal how MC² governs matter under pressures and densities that transform the very nature of atomic structure. Massive stars constantly eject matter through stellar winds that carry kinetic energy equivalent to millions of nuclear bombs per second. Over millions of years, these energetic outflows sculpt vast nebulas, using stellar mass as cosmic construction material to create some of the most beautiful structures in space. Star formation regions become cosmic construction sites where energy and matter dance together to build new solar systems. The universe is not in energetic equilibrium. Due to cosmic expansion driven by dark energy, galaxies are moving away from each other at accelerating rates. This means the total energy accessible to any given region of space is continuously decreasing as matter and energy move beyond the cosmic horizon. The universe is evolving toward a state where available energy becomes increasingly diluted across ever larger volumes of space. The first stars in cosmic history burned their nuclear fuel 100 times faster than modern stars, living only millions of years, but shining with such intensity that they forged the first heavy elements through extreme nuclear fusion. These primordial giants operated under conditions of temperature and pressure that allowed MC² to create elements impossible to produce in today's cooler, more mature universe. Without these ancient stellar furnaces, the complex chemistry necessary for planets and life could never have developed. The ultimate fate of the cosmos reveals the final destiny of Einstein's equation. In trillions of years, the last stars will burn out and the last black holes will evaporate through Hawking radiation. Eventually, all the mass in the universe will have been converted to energy in the form of low-temperature radiation dispersed across infinite, cold, dark space. This represents the final victory of MC², a future where every atom that ever existed will have been transformed into energy, spreading through a cosmos grown so vast and cold that no further energy transformations will be possible. But there's something deeply profound about this cosmic story that goes beyond physics and mathematics. In September 1905, when Einstein first glimpsed the relationship between mass and energy, he experienced what he would later describe as a moment of revelation that bordered on the mystical. Picture Einstein in that small patent office in Bern, surrounded by applications for mundane inventions, when suddenly the fundamental architecture of reality revealed itself to him. It wasn't just that he had discovered a new scientific fact. He had uncovered what he would call the secret recipe of the universe, a mathematical truth so fundamental that it connects matter, energy, space, and time in a single, elegant relationship. This wasn't merely a human discovery. Einstein realized he had found something that transcends cultures, epochs, and even species. Any intelligent civilization anywhere in the cosmos that studies the physical world would inevitably arrive at this same relationship. MC² isn't human mathematics, it's universal language. Einstein often spoke of his equation as revealing the mind of God, not in any religious sense, but as recognition that reality operates according to principles of breathtaking unity and simplicity. What appears to us as separate phenomena, solid matter and radiant energy, are actually different aspects of the same fundamental essence. Before MC², we lived in a world of apparent opposites: matter versus energy, substance versus motion, body versus force. Einstein revealed that these distinctions are illusions created by our limited perspective. At the deepest level, reality is unified. After discovering MC², Einstein spent the last 30 years of his life searching for something even more fundamental, a theory of everything that would unify gravity, electromagnetism, and the nuclear forces in a single mathematical framework. He dreamed of finding one equation that would describe all possible physical behavior, like discovering the personal signature of creation itself, written into the fabric of existence. Though he never found this ultimate equation, his quest revealed something profound about the nature of mathematical truth. MC² works not just in our three-dimensional universe, but would function identically in two-dimensional flatlands, or hyperdimensional realities that we can barely imagine. This universality suggests that mathematical principles exist independently of the specific geometry of space and time. The equation reveals logical structures that seem to precede and determine the nature of physical existence itself, as if the universe is fundamentally mathematical rather than merely describable by mathematics. Consider the speed of light in Einstein's equation. This isn't an arbitrary number that humans happen to measure. It represents the absolute speed limit for information in the universe, the cosmic speed limit built into the very structure of space and time. The fact that this universal constant appears in the mass-energy relationship suggests that our reality operates according to precise mathematical constraints that prevent logical paradoxes and maintain cosmic consistency. The universe seems designed to avoid contradictions, as if governed by an intelligence that values logical coherence above all else. Einstein was perpetually amazed by what he called the unreasonable effectiveness of mathematics in describing physical phenomena. How is it possible that numerical relationships discovered by human minds correspond so perfectly to the behavior of distant galaxies and subatomic particles? It's as if mathematics exists independently of human consciousness, waiting to be discovered by any intelligence sophisticated enough to recognize numerical patterns. This suggests that mathematics might be the fundamental language of creation itself. Hidden within ʻOumuamua is a beautiful symmetry that reveals the deep logic of reality. When particles accelerate to nearly the speed of light, their relativistic mass increases in exactly the way required to keep the total energy relationship intact. The universe preserves mathematical proportions even under the most extreme conditions. This isn't coincidence. It's evidence of underlying principles that maintain consistency across all possible scales and circumstances. The equation also makes absolute predictions about physical impossibilities. Objects with mass cannot reach the speed of light because doing so would require infinite energy. This isn't a technological limitation that advanced civilizations might overcome. It's a fundamental constraint built into the logical structure of reality itself. No matter how advanced a species becomes, certain physical laws cannot be violated through engineering or cleverness. The universe operates according to inviolable mathematical rules. MC² connects seamlessly with Einstein's other great discoveries: special relativity, general relativity, and the photoelectric effect, forming an integrated intellectual framework of almost religious beauty. Each discovery illuminates and strengthens the others, like pieces of a cosmic puzzle that, when assembled, reveal the fundamental architecture of space, time, matter, and energy. This isn't a collection of separate scientific facts, but a unified vision of reality that achieves the kind of conceptual elegance that Einstein associated with divine thought. God is subtle, but not malicious, Einstein once said, reflecting his belief that the universe's fundamental laws should be elegantly simple rather than arbitrarily complex. MC² exemplifies this philosophy: three symbols, expressing a truth so profound that it governs phenomena from quantum mechanics to cosmic evolution. The equation suggests that apparent complexity emerges from basically simple principles, like infinite musical variations arising from a small number of fundamental notes. What makes MC² truly remarkable is its temporal universality. This relationship functioned during the first second after the Big Bang, operates today in every chemical reaction and nuclear process, and will continue governing energy transformations when the last stars burn out trillions of years from now. Some mathematical truths transcend time itself, representing eternal aspects of reality that remain constant while everything else evolves and changes. The equation's objectivity is equally profound. MC² yields identical results whether measured by humans, hypothetical aliens, or advanced artificial intelligences. This universality suggests the existence of objective truths accessible to any mind capable of mathematical reasoning. The equation becomes a bridge connecting all possible intelligences through shared discovery. Any conscious species that investigates the physical world will eventually uncover this same fundamental relationship. Einstein frequently described equations in aesthetic terms, using words like beautiful and elegant to characterize mathematical relationships. MC² produces an experience comparable to great music or art. It satisfies not just intellectual curiosity, but deeper aesthetic sensibilities. This suggests that fundamental truths possess qualities that transcend mere utility, touching dimensions of conscious experience that connect reason with emotion, analysis with wonder. When you truly contemplate MC², you should feel a sense of awe bordering on reverence, like standing before a great cathedral or hearing a sublime symphony, the equation evokes recognition of an order that exists beyond human limitations and preconceptions. This humbling experience connects the individual mind with cosmic principles, revealing that mathematical discovery is a form of communion with the fundamental nature of reality itself. The same equation governs processes in subatomic particles and supergiant stars, identical mathematical principles operating across scales that differ by 40 orders of magnitude. From the smallest quarks to the largest galactic structures, MC² reveals unity, underlying apparent diversity. This suggests a universe of extraordinary consistency, where the same logical principles govern all phenomena, regardless of scale, distance, or temporal location. Einstein's equation challenges every intuition that human evolution provided for navigating daily life. Our ancestors needed to treat solid objects as permanent and energy as separate from matter. These assumptions helped them survive, but they're fundamentally incorrect. MC² reveals that our natural perceptions are useful illusions that mask deeper realities. This discovery requires intellectual humility, accepting that the universe is stranger and more wonderful than common sense suggests. Einstein often described his moments of scientific insight as quasi-mystical experiences, where universal truths revealed themselves through pure mathematical contemplation. MC² represents the culmination of such a journey, a connection between individual human consciousness and the principles that govern cosmic existence. This suggests that scientific discovery at the highest levels becomes a form of spiritual practice, a communion with transcendent truths through disciplined intellectual effort. The equation forced philosophers to reconsider basic concepts like substance, causality, and identity. If matter can transform into pure energy, what does existence really mean? If solid objects are temporary patterns of energy, what constitutes identity over time? When MC² opened philosophical questions that continue expanding the boundaries of human thought, proving that scientific discoveries can reshape fundamental categories of understanding. Artists, writers, musicians, and filmmakers have drawn inspiration from MC² because it represents perfect union between scientific precision and conceptual beauty. The equation touches universal dimensions of aesthetic experience that transcend academic categories. Creative minds recognize in MC² an expression of truth that connects rational analysis with emotional resonance, proving that the deepest discoveries satisfy both intellectual and artistic sensibilities. Perhaps most remarkably, MC² possesses a form of immortality that transcends human civilization. Even if our species vanishes, this mathematical relationship will remain true. Any future intelligence that investigates physical reality will inevitably rediscover the same fundamental connection between mass and energy. Einstein's insight possesses eternal validity that connects all possible minds across space and time through shared mathematical truth. Yet even this most fundamental of equations has limits, absolute boundaries beyond which our understanding breaks down, and reality itself might operate according to principles we can barely imagine. Consider what happens when objects approach the ultimate speed limit of the universe, 209,792,458 meters per second. As anything with mass accelerates toward the speed of light, something extraordinary occurs. According to MC², the object's relativistic mass begins to increase, requiring ever more energy to achieve each increment of additional speed. At 90% light speed, the energy required doubles. At 99%, it increases tenfold. At 99.9%, it becomes 50 times greater. As the object approaches light speed, its mass approaches infinity, meaning it would require infinite energy to push it that final increment. This isn't a technological limitation that some advanced civilization might overcome with better engineering. It's an absolute barrier built into the fundamental structure of space-time itself. The universe simply forbids massive objects from reaching light speed, not through arbitrary rules, but through the inexorable logic of Einstein's equation. The speed of light represents more than just a velocity. It's the cosmic speed limit that prevents paradoxes and maintains the logical consistency of cause and effect. When we square the speed of light in Einstein's equation, we get 8.98 x 1016 meters squared per second squared. This represents the maximum possible efficiency for converting mass into energy. No physical process, no matter how exotic or advanced, can extract more energy per kilogram than the complete conversion predicted by MC². This establishes an absolute ceiling for energy density anywhere in the universe. Even hypothetically perfect energy conversion cannot exceed this fundamental limit. The most efficient energy conversion process we know occurs when matter meets antimatter. When a particle encounters its antiparticle counterpart, they annihilate each other completely, converting 100% of their combined mass into pure energy, according to MC². This releases 1.8 x 1017 joules per kilogram, enough energy to vaporize entire mountains. Yet even this perfect conversion represents the absolute theoretical maximum efficiency. The universe provides no mechanism for exceeding this limit. But Einstein's equation faces its greatest challenges in the most extreme environments imaginable. At the edge of black holes, where gravity becomes so intense that space and time themselves become distorted beyond recognition, our traditional concepts of mass and energy begin to break down. Near the event horizon, the boundary beyond which nothing can escape a black hole's gravitational pull, space-time curves so severely that MC² may assume forms we don't yet understand. Physics predicts an ultimate temperature, the Planck temperature of 1.42 Ke 1032 Kelvin. Beyond this point, thermal energy becomes so intense that the very structure of space-time would disintegrate into quantum foam. At such temperatures, the concepts of mass and energy that underpin MC² might lose all meaning. We're approaching conditions where reality itself becomes physically impossible to describe using our current understanding. Even with perfect mass-energy conversion, the universe imposes an absolute limit on available energy. The observable universe contains approximately 1.5 x 1053 kilograms of matter, which translates to a maximum of 1.35 x 1070 joules of energy. This represents an absolute ceiling that no civilization, regardless of technological advancement, can exceed. The cosmos is fundamentally finite, imposing ultimate constraints on what's physically possible. At the smallest scales, reality becomes equally strange. The Planck length, 1.6 x 1035 meters, represents the smallest distance that has physical meaning. Below this scale, the smooth geometry of space-time breaks down into discrete, granular structures where classical physics no longer applies. MC² assumes continuous space and time, but at Planck scales, the universe may operate according to entirely different principles. Even empty space challenges our understanding. Quantum mechanics reveals that the vacuum isn't truly empty, but seethes with virtual particles constantly appearing and disappearing. These quantum fluctuations suggest that empty space itself possesses energy density that might be infinite. This forces physicists to question whether zero energy has any meaningful definition, and whether MC² adequately describes reality at quantum scales. Black holes present another fundamental challenge through Hawking radiation. Stephen Hawking predicted that black holes slowly evaporate by emitting thermal radiation, eventually converting all their mass into energy. This process represents a convergence of quantum mechanics, general relativity, and MC² operating under conditions impossible to replicate in laboratories. The physics of evaporating black holes pushes our theories to their absolute limits. The expansion of the universe itself creates a cosmic horizon beyond which escape becomes impossible. To leave the observable universe would require exceeding the speed of light, a violation of MC² that reveals how Einstein's equation and relativity together create an inescapable cosmic prison. We exist within absolute boundaries that no amount of technology or cleverness can transcend. Time itself has fundamental limits. The Planck time, 5.4 x 10^44 seconds, represents the smallest interval during which cause and effect have meaning. Below this timescale, the sequential relationships necessary for mass-energy conversion become meaningless. MC² may simply not apply in a reality where time loses its sequential nature. Advanced theories like supersymmetry suggest that mass-energy relationships might be more complex than MC² reveals, especially near the Planck scale. Einstein's equation might represent only a special case of deeper truths that remain hidden from our current understanding. We may be seeing only the visible portion of a vast iceberg of physical reality. The universe's critical density, 9.9 x 10^27 kilograms per cubic meter, determines whether cosmic expansion continues forever or eventually reverses. This value connects MC² to the ultimate fate of everything that exists, demonstrating how local energy density influences the global geometry of space-time. Even the destiny of the cosmos depends on energy relationships governed by Einstein's equation. String theory proposes that reality contains 11 dimensions, with only 3 spatial dimensions accessible to our experience. If this is correct, energy and mass might leak into hidden dimensions, modifying MC² in unpredictable ways and revealing fundamental limitations in our 3-dimensional physics. We might be studying only a shadow of true reality. Dark energy, which accelerates cosmic expansion, represents 68% of the universe, yet produces effects that seem to violate basic assumptions about energy and gravity. This mysterious force may represent a fundamental limitation of MC² for describing exotic energy forms that operate according to principles beyond current physics. The majority of the universe might be governed by physics we don't understand. The hierarchy problem reveals another mystery. Gravity is 1036 times weaker than electromagnetism for reasons no one can explain. This enormous discrepancy suggests fundamental gaps in our understanding of how MC² relates to other universal constants. Our deepest physical theories may be missing crucial pieces of the cosmic puzzle. Quantum uncertainty allows temporary violations of energy conservation at subatomic scales, where particles can briefly borrow energy from the vacuum before returning it. These quantum loans reveal limitations of MC² when quantum mechanics dominates over classical physics. Reality at its smallest scales operates by different rules than the macroscopic world. At absolute zero temperature, thermal motion ceases, but quantum fluctuations persist, creating a state where classical concepts of energy become ambiguous. Even when everything appears motionless, quantum activity continues according to principles that challenge traditional interpretations of MC². Complete energetic rest may be impossible in a quantum universe. The black hole information paradox suggests that information might be preserved even when the mass energy that encoded it is destroyed. If information possesses independent physical reality, then MC² may not capture the complete picture of what actually exists. The relationship between energy, matter, and information remains one of physics' deepest mysteries. All of these extreme conditions point toward the same sobering conclusion. MC² may represent only an approximation that works under limited conditions of temperature, pressure, and energy density. Beyond certain extremes, the laws of physics might assume completely different forms that render Einstein's equation irrelevant. Even our most fundamental discoveries possess absolute limits and frontiers that remain unexplored. The universe may be far stranger than even Einstein imagined, operating according to principles that transcend our current understanding and perhaps even our capacity to comprehend. But perhaps the most profound realization about Einstein's equation isn't found in cosmic extremes or mathematical abstractions. It's found in looking at yourself, right here, right now, and understanding what you actually are. The carbon in your muscles, the oxygen in your lungs, the iron in your blood, the calcium in your bones, every single one of these elements was forged in the nuclear furnace of a star through fusion reactions governed by MC². You are literally made of stardust that has achieved consciousness. Think about this for a moment. The atoms that compose your body are older than the Earth itself. They were created billions of years ago in stellar cores, where temperatures exceeded 100 million degrees, where MC² transformed hydrogen into the heavier elements that make complex chemistry, and therefore life, possible. Before stars existed, the universe contained only hydrogen and helium. It was a cosmos without carbon, without oxygen, without any of the elements necessary for planets, oceans, or living things. Only through billions of years of stellar alchemy, powered by Einstein's equation, did the universe transform from a simple collection of light gases into the rich, complex reality we inhabit today. Every breath you take contains atoms that once burned in the heart of ancient suns. The energy that keeps you alive right now comes from chemical reactions that release about 2,000 joules per day. Energy extracted from food through processes that echo MC² on a molecular scale. Life itself is a temporary energetic phenomenon that borrows energy from the universe for a few decades before returning it through natural decomposition. You are not a permanent structure. You are a dynamic process, a temporary organization of cosmic energy that has learned to think and feel and wonder about its own existence. When you consider the astronomical odds against your existence, the picture becomes even more extraordinary. The probability that atoms would spontaneously organize themselves into conscious beings capable of understanding their own atomic composition approaches zero. It's like expecting an explosion in a library to produce a perfectly organized encyclopedia. Yet here you are, a statistical impossibility made real, an arrangement of stellar debris that has become aware of itself. The atoms in your body have been recycled countless times throughout Earth's history. The carbon in your DNA may have once been part of a dinosaur's backbone, a primordial plant's leaves, or another human being who lived centuries ago. Matter circulates perpetually through different living forms, creating an unbroken chain of material connection that links all life across time. You share atoms with every person who ever lived. MC² governs the transformations that connect you physically with all of history. Understanding that you are a temporary pattern of condensed energy dissolves many illusions about personal permanence. You're not a solid object moving through space and time. You're more like a wave in an ocean, maintaining a recognizable form, while the substance that composes you flows constantly through and around you. Your identity is not a thing, but a process, not a noun but a verb, not a permanent fixture but a dynamic dance of energy that will continue in new forms long after your current pattern dissolves. In a universe 13.8 billion years old, containing hundreds of billions of galaxies, you represent something remarkable. Matter that has organized itself into a form capable of understanding its own fundamental nature. Through human consciousness, the cosmos has developed the ability to contemplate itself. You are literally the universe becoming self-aware. Consider the miracle of your understanding. Your brain, composed entirely of elements forged in stellar cores, can deduce the mathematical equations that describe how those same stellar cores operate. The products of cosmic processes have developed the capacity to comprehend the principles that created them. This represents an extraordinary circular achievement, the universe using a tiny portion of itself to understand the whole, matter becoming conscious of the energy relationships that govern its own existence. Every technology that surrounds you depends on principles derived from MC², the electricity powering your devices, the fuels that transport you, the nuclear medicine that can heal you, all represent applications of Einstein's insight. Human civilization is fundamentally an energetic phenomenon, a complex system for organizing and transforming energy according to intelligent design. We exist as temporary arrangements of cosmic forces, using our brief moment of consciousness to reshape energy patterns for our own purposes. The requirements for conscious life are so specific and rare that you may represent an extraordinary exception in a universe dominated by lifeless matter. The precise combination of elements, temperatures, pressures, and evolutionary time needed to produce intelligence suggests that consciousness might be profoundly isolated in the cosmic vastness. If this is true, then your ability to understand MC² makes you part of a vanishingly small minority of matter that has achieved self-awareness. Your individual existence is energetically temporary. The pattern that constitutes your physical being will dissipate within decades. But the information and knowledge you can transmit to others creates a form of limited immortality. Scientific discoveries like MC² transcend the lifespans of their discoverers, achieving a kind of permanence that individual biology cannot. Through communication and education, consciousness can persist beyond the energetic patterns that originally created it. You exist during a privileged epoch in cosmic history. Stars still burn brightly, providing energy for complex chemistry and life. In the distant future, when the universe becomes cold, dark, and energetically exhausted, consciousness like yours may become impossible. You live in a brief window of cosmic time when the universe is neither too young for complexity nor too old for energy, a moment when matter can organize itself into forms capable of understanding its own deepest principles. Even your emotions represent sophisticated forms of energy organization. Love, wonder, curiosity, and joy emerge from neurological processes that consume biochemical energy in patterns of extraordinary complexity. The most meaningful experiences of human existence are fundamentally energetic phenomena, governed by the same principles that operate in stellar cores. When you feel moved by beauty or connected to another person, you're experiencing highly organized manifestations of the cosmic energy dance. Human creativity mirrors the creativity of the cosmos itself. Art, music, literature, and scientific discovery represent the reorganization of neural energy into new informational patterns. This creative process echoes the way primordial energy has organized itself into increasingly complex structures throughout cosmic history, from particles to atoms to molecules to life to consciousness to culture. Your imagination participates in the same fundamental creative force that built galaxies and kindled stars. The human search for meaning might itself reflect a universal tendency of energy to organize into ever more complex patterns. Consciousness appears to be the cosmos developing an appetite for understanding itself, using biological intelligence as an instrument for self-contemplation. Your need to find purpose may be the universe's way of examining its own nature through the temporary lens of human awareness. When your individual pattern dissolves, the atoms that currently compose your body will return to the environment and eventually incorporate into other living forms. Death represents a change in organization, not annihilation of substance. The matter that is temporarily, you will continue participating in the energy cycles that connect all earthly life. Individual boundaries are temporary conveniences. At the deepest level, you are part of an unbroken web of matter and energy that encompasses everything. Understanding that mass and energy are aspects of the same fundamental reality dissolves traditional distinctions between material and spiritual experience. If everything is energy organized in different patterns, then consciousness itself might represent energy arranged in configurations sufficiently complex to generate subjective experience. MC² suggests that the physical and metaphysical might be different perspectives on the same underlying unity. Scientific instruments extend your consciousness far beyond biological limitations, allowing you to detect MC² operating across scales from subatomic to cosmic. Through technology, you become a sensor capable of perceiving the universe's energetic relationships across all accessible dimensions. Your awareness, amplified by tools, can encompass the full range of scales where Einstein's equation governs reality. With the power to understand and manipulate MC² comes profound responsibility. Nuclear energy, genetic engineering, and other applications of Einstein's insights require wisdom that matches their potency. Knowledge of fundamental energy relationships carries ethical obligations to preserve the conditions that allow consciousness to flourish. Understanding the cosmos imposes moral duties for protecting the intelligence that makes such understanding possible. Even if human civilization eventually vanishes, the energetic modifications we've made to Earth, our buildings, our technologies, the radioactive signatures of our nuclear activities, will persist for millions of years. These changes represent our species' permanent signature in the planet's energy patterns, proof that once there existed beings capable of comprehending and applying MC². Through our technological impact, we achieve a form of geological immortality, leaving traces of intelligence embedded in the Earth's energetic structure long after biological memory fades. But Einstein's equation doesn't just reveal what we are, it illuminates what we might become. MC² holds the key to humanity's transformation from a planetary species into something far greater. Nuclear fusion propulsion could accelerate spacecraft to 10 to 15% of light speed, making interstellar voyages achievable within human lifetimes. Instead of journeys lasting thousands of years, we could reach nearby star systems in decades. This technology would transform us from a single-world civilization into a galactic species, using artificial stellar engines to navigate between solar systems, just as ancient mariners used ocean winds to cross terrestrial seas. The energy requirements are staggering but achievable. Accelerating a 1,000-ton spacecraft to 10% light speed requires energy equivalent to global electricity production for an entire century. This demonstrates that galactic exploration will demand mastery of MC² on scales that transcend our current capabilities, forcing development of energy technologies that are fundamentally revolutionary. The ultimate rocket fuel would be antimatter, matter's perfect opposite that annihilates completely upon contact, converting 100% of mass to energy according to Einstein's equation. Just 1 kilogram of antimatter could propel an interstellar vessel to velocities approaching light speed, transforming journeys that would take millennia into expeditions measured in decades. This represents the theoretical maximum efficiency for space propulsion, the perfect realization of MC² for transportation across cosmic distances. On Earth, controlled fusion reactors will recreate stellar processes in terrestrial facilities, providing virtually unlimited energy through mass energy conversion of hydrogen from our oceans. This technology would make our civilization independent of fossil fuels while supporting billions of people through domesticated stellar power. We would literally learn to build and operate artificial stars, bringing cosmic energy production down to planetary scale. Space-based solar collectors could capture stellar energy without atmospheric interference, beaming gigawatts to Earth through microwave transmission. This would transform our entire solar system into an integrated energy network, supporting expanded civilization across multiple worlds through industrial-scale application of MC² principles. The Sun would become our local power plant, feeding energy to human settlements from Mercury to the outer planets. In 5 billion years, our aging Sun will expand into a red giant, vaporizing the inner planets and making Earth uninhabitable. This cosmic deadline makes interstellar migration not an optional adventure, but an evolutionary necessity for species survival. MC² provides the energetic foundation for this mandatory exodus, transforming interstellar colonization from science fiction dream into biological imperative. We must learn to use Einstein's equation to carry life itself to other stars. Terraforming hostile worlds will require energy equivalent to thousands of nuclear weapons applied over centuries in controlled, constructive ways. We could melt Martian ice caps, thicken planetary atmospheres, and modify entire climates through planetary-scale energy manipulation governed by MC². This would represent environmental engineering on geological scales, using stellar-level energy to remake worlds according to biological requirements. Future telescopes will detect the energy signatures of advanced civilizations by identifying spectral evidence of controlled fusion or massive stellar engineering projects. Astronomy will become cosmic archaeology, searching for intelligence through anomalous energy patterns in distant star systems. We'll look for other species by finding evidence of their mastery of Einstein's equation. Sufficient energy control might enable precise atomic manipulation to reconstruct DNA from extinct species, potentially reversing extinctions through energetically intensive genetic engineering. This would demonstrate subatomic mastery of ʻOumuamua, using Einstein's principles to resurrect vanished life forms through molecular-scale energy application. We could become cosmic gardeners, restoring biodiversity through pure energy manipulation. Fusion-powered lasers could transmit information across interstellar distances, establishing communication networks with distant civilizations through detectable energy pulses. This would create a galactic internet connecting intelligent species through energy-based protocols, founded on MC² as universal language. Mathematical relationships governing energy and mass might become the foundation for cosmic communication. Hypothetical Type 3 civilizations might harness energy from entire galaxies through megastructures that capture radiation from billions of stars simultaneously. This would represent complete mastery of MC² on galactic scales, transforming advanced species into cosmic forces capable of reshaping stellar architecture. Such civilizations would become indistinguishable from natural astronomical phenomena. Carbon nanotube cables connecting Earth's surface to orbital altitude could reduce space access costs by factors of thousands through revolutionary energy efficiency. This infrastructure would democratize space exploration, making orbital travel as routine as contemporary air transportation. The energy barrier between Earth and space would essentially disappear. Metallic asteroids contain enough platinum, gold, and rare elements to sustain advanced civilization for millions of years. Exploiting these resources will require nuclear-powered spacecraft and processing facilities, demonstrating how MC² enables utilization of solar system-wide material wealth. The asteroid belt would become humanity's industrial foundation. Artificial intelligence might optimize energy utilization with efficiency impossible for biological brains, designing perfect fusion reactors and energy distribution systems. Human-AI collaboration could accelerate our mastery of MC² through hybrid intelligence that combines human wisdom with computational optimization. Silicon minds might unlock energy secrets that carbon brains cannot discover alone. Quantum storage systems powered by nuclear energy could preserve human knowledge through cosmic timescales, protecting discoveries like MC² against civilizational collapse or species extinction. This would create cultural immortality through energetically sustained information preservation. Our ideas could outlive our biology by billions of years. Abundant fusion energy would enable controlled genetic modification to adapt humans for extraterrestrial environments. Energy-intensive biological engineering could accelerate evolution, creating human variants specialized for different planetary conditions through directed energetic intervention in genetic development. We might diversify into multiple related species optimized for cosmic exploration. Remaining confined to Earth exposes humanity to existential risks from asteroid impacts, supervolcanic eruptions, or cosmic catastrophes. Interstellar dispersal using MC²-based propulsion represents survival strategy through galactic redundancy, ensuring consciousness survives even planetary-scale disasters. Spreading across the galaxy becomes our insurance against cosmic accidents. Energy abundance through controlled fusion could eliminate resource scarcity, potentially ending poverty and material conflicts while liberating human potential for scientific exploration, artistic creation, and spiritual development. Post-scarcity society would redirect energy from survival toward transcendence. We could finally focus on becoming rather than merely surviving. Unifying MC² with quantum mechanics and gravitational theory might reveal energy dimensions beyond current physics, potentially enabling space-time manipulation, instantaneous travel through dimensional folding, or access to energy sources that transcend known physical limitations. Future physics might make our current understanding look primitive. Sufficiently advanced civilizations might learn to manipulate MC² in ways that preserve consciousness beyond the heat death of the universe. Intelligence could become a cosmic force capable of transcending physical limitations, creating forms of existence that persist through fundamental cosmological transitions. Mind might ultimately prove more durable than matter itself. This represents the ultimate promise of Einstein's equation, not just understanding the universe's energy relationships, but mastering them so completely that consciousness itself becomes a cosmic phenomenon capable of reshaping reality according to intelligent design. We stand at the beginning of a journey that could transform thought itself into a force of nature, using the wisdom hidden in 3 simple symbols to illuminate pathways toward transcendence that we can barely imagine. Let's pause for a moment and consider the remarkable journey we've taken together. We began with a simple equation, 3 symbols that you've probably seen countless times before. E equals MC². But what started as abstract mathematics became something far more profound, a revelation about the deepest nature of reality itself. We discovered that your coffee mug contains more energy than the largest nuclear weapon ever detonated. That every grain of rice harbors the power to level city blocks. That you yourself are a walking constellation of compressed starlight, carrying cosmic forces in every cell of your body. But MC² is more than mathematics. It has become a bridge between scientific knowledge and existential wisdom, revealing that we are simultaneously insignificant and extraordinary. We are cosmic dust that has somehow learned to contemplate the universe that created it. Think about the magnitude of this paradox. You are made of particles so small that trillions could fit on the head of a pin, yet you possess the capacity to understand laws that govern galaxies spanning hundreds of thousands of light years. Einstein's equation fundamentally changed how we perceive reality. Before 1905, we inhabited a mechanical universe of solid objects moving through empty space according to predictable laws. After MC², we discovered we live in an energetic cosmos where matter and radiation engage in perpetual transformation according to mathematical principles of breathtaking elegance. Reality transformed from a machine into a symphony. This knowledge brings profound responsibility. Understanding MC² means recognizing that our species has developed the power to release energy sufficient to destroy civilization or illuminate our path to the stars. Scientific discovery has become a moral test of our wisdom and maturity when confronted with literally cosmic forces. We hold the keys to both ultimate destruction and infinite creation. Every atom in your body was forged in stellar cores through processes governed by Einstein's equation. You're not an external observer of the cosmos, but an intimate participant in its ongoing story. You carry billions of years of energetic history in every cell, connecting you physically and spiritually with cosmic origins and destinies. You don't just live in the universe. You are the universe experiencing itself through temporary human consciousness. Einstein's solitary work in a Swiss patent office altered the trajectory of human civilization through pure intellectual insight. This demonstrates that individual ideas can reverberate across generations, proving that every human mind carries potential for discoveries that reshape our collective understanding of fundamental reality. Single thoughts can change the course of species. The passion, curiosity, love, and wonder that drive scientific discovery are forms of neural energy that echo the energetic processes governing cosmic evolution. Our highest motivations participate in the same universal dance that moves planets and ignites stars, suggesting deep connections between human consciousness and cosmic creativity. Your emotions resonate with the energy patterns that organize galaxies. MC² functions identically regardless of culture, language, or historical epoch. This universality suggests that any intelligence anywhere in the cosmos will discover identical mathematical relationships, revealing mathematics as the fundamental language that could connect all possible minds through eternal numerical truths. Math might be the universe's way of talking to itself across space and time. The energy from the Big Bang flows through stars, planets, living organisms, and eventually human consciousness in an unbroken stream spanning 13.8 billion years. We are temporary moments in this cosmic current, transforming ancient energy into contemporary experience through biological processes that briefly organize stellar debris into awareness. You are the cosmos becoming conscious of itself for a brief, brilliant moment. 3 symbols explain energetic behavior from subatomic particles to galactic superclusters. This elegant simplicity reveals the universe's apparent preference for fundamental principles of mathematical beauty over unnecessary complication, as if reality operates according to aesthetic values that favor elegance over complexity. The cosmos appears to be an artist as much as an engineer. We live during a unique historical moment, the first centuries since humanity discovered MC² and began manipulating nuclear energy. We're witnessing our species' transformation from passive observers to active participants in cosmic evolution through conscious technological intervention. We've become co-creators in the ongoing story of energy and matter. Einstein's equation guarantees that energy never truly disappears. It merely transforms, circulating perpetually through different configurations while connecting past, present, and future in an unbreakable chain. Nothing is ever permanently lost, only changed into new forms through endless metamorphosis. This offers profound comfort. Nothing you are or create ever completely vanishes. MC² reveals that apparent distinctions between solid matter, radiant light, thermal heat, and kinetic motion are useful illusions masking fundamental unity. Everything is energy wearing temporary disguises, demonstrating that diversity emerges from singular essence, expressing itself through infinite possible manifestations. Separation is the grand illusion. Connection is the deepest truth. Encountering MC² should inspire wonder rather than mere technical comprehension. The equation reveals that we inhabit a universe more extraordinary than any fiction, where simple laws generate infinite complexity and consciousness emerged from chaos to contemplate its own magnificent improbability. Amazement is the appropriate response to our cosmic situation. A century after Einstein's discovery, we continue finding new applications: dark energy, gravitational waves, quantum teleportation. This suggests that his equation remains a portal to unexplored territories of physics, ensuring future generations will keep discovering implications of this apparently simple truth. The adventure of understanding has only just begun. Although individual bodies dissolve, discoveries like MC² transcend personal mortality. Mathematical truths persist indefinitely, ensuring humanity's deepest insights survive across generations through collective intellectual immortality, where accumulated knowledge represents our species' permanent legacy. Ideas outlive the minds that birthed them. Einstein's equation reveals we are simultaneously products of universal forces and unique comprehenders of those same forces. This paradoxical position demands humility before cosmic grandeur, while accepting responsibility for extraordinary knowledge, balancing physical insignificance with intellectual significance. We must be both humble and bold. Understanding MC² transforms ordinary people into conscious participants in the cosmic adventure. Scientific education becomes spiritual awakening that reveals hidden connections between personal experience and universal reality, demonstrating that learning science is a form of enlightenment, expanding individual identity to galactic dimensions. Knowledge is the pathway to cosmic citizenship. MC² represents only the first chapter of humanity's journey toward understanding the cosmos. Future discoveries may reveal even more fundamental truths, ensuring our species will have intellectual frontiers to explore for millennia while maintaining purpose through perpetual pursuit of deeper knowledge. The greatest discoveries still await us. Einstein's equation is ultimately the universe's invitation to participate consciously in the cosmic dance of energy and transformation. It offers the opportunity to elevate human existence from biological accident to active partnership with the creative intelligence that organizes reality through mathematical laws of transcendent beauty. We are being invited to become collaborators in the ongoing creation of cosmos itself. If you're still awake, it's because the content was really good. So, take a moment, leave a like and subscribe to the channel. It helps a lot. And if you want to keep watching, just click on the video that's appearing right now.